Okay, we're going to make a start on algebra. Now, I know the world of known, concrete, unchanging numbers is where you're probably most comfortable, and as soon as these letters come out, things start getting a bit freaky, and the question that so many people seem to be worried about is, what is x? And granted, there might be some cases where we're trying to work that out, and you're going to see ways of doing so when that's required, but that's kind of dodging the whole point of algebra, which is to not be scared of working with numbers you can't see. So maybe a better question to ask is why on earth anybody would want to do that, right? Why do you want to be able to work with numbers that you can't see? And really, this is more a conversation to have live or in person, but I'll at least try and give a brief introductory story here. Let's start by writing down some little number facts. Obviously, 2 is 1 times 2, nothing special there. But actually, 2 plus 4, so adding the next even number, is 6, which happens to be 2 times 3. Then adding 6, the next even number, gives you 12, which happens to be 3 times 4. And one more, adding 8, the next even number, gives you 20, which happens to be 4 times 5. And it would seem to go on, and I know you probably believe it does, but actually, you have no reason to believe that this pattern continues. See, what if it's just a coincidence? What if it just keeps on doing that for a while, but then suddenly it stops behaving like this after getting to maybe hundreds or thousands or even millions? How could you be sure? Right? Now, algebra is massive. It quite literally changed the whole game of maths for the entire human race, and so I can't hope to demonstrate all its power to you in these few minutes. But if there's one thing I want you to know about algebra and take away from this topic, it's that at the very least it gives you a language to describe patterns and relationships. See, this list of number facts could well go on forever, and we can only write and check so many of them before getting very hungry or something. But what if we could write down not just a single sentence to check, so whether or not 2 plus 4 plus 6 is indeed equal to 3 times 4 or something, but what if we wrote down the entire pattern, the whole relationship we're trying to investigate here in one single line? So you might be like, well, what is n then? But it is exactly the fact that we don't know and we don't care what n is that makes this one sentence so incredibly powerful. The fact that n could be anything means that this one sentence now carries all the information here. And if we could somehow prove that this one sentence, this one single sentence is true, we would automatically have checked every single possibility in that list, and there would be zero chance of it misbehaving further down the track. And that's very cool. Right? It is one thing that makes algebra so powerful and so useful in the world of maths. And so letting go of fixed numbers and being willing to dive into this language of patterns, of relationships, is sort of what allows us to see that the mathematical models underneath, say, the cooling of soup, or the growth of a population of rabbits, or say even the spread of a virus, right? It's actually all the same maths. And the power that algebra gives us to analyze not just individual numbers, but patterns and relationships in nature and in numbers all around us, that's what lets all this happen and so much more. Okay, so all that to say, there is good in being able to talk about numbers we cannot see, numbers that we don't know. I like to think of these at first as something like a box of Smarties. There's some number in there you don't know, and that is perfectly fine. Okay, and we often use letters to represent such numbers, so as is tradition, we'll call this guy x. We can still use all the other symbols we know in maths, so if we throw in 3 extra Smarties and count up how many we have in total here, that would naturally be x inside the box, then plus the 3 extra outside. Okay, should be no surprises there, but I want you to really keep this picture in mind for what we do later. It'll be quite useful. Likewise, if we took 2 Smarties out of the box, we'd have x minus 2 because we're taking 2 away. If we were to duplicate our box, we now have 2 boxes, so naturally we'd write 2x. But what does this really mean? Well, let's cheat by peeking inside the box. Say we find there are 10 Smarties in each one. Then all up, we'd have 20. But maybe we got really cheap boxes with only 4 inside. All up, we'd have 8. Maybe we got an enormous box, 100 Smarties each, then all up we'd have 200. Okay, remember, algebra is all about describing patterns, and hopefully you see the pattern here is that however many Smarties there are in each box, we're multiplying by 2 to see how many we have in total. So whenever we write things like 2x, or even later xy, or whenever there's nothing in between, we're just writing two things stuck together like that, it's good to know we're actually just hiding a multiplication sign in there, and that's what it means. Okay, so that's all for this one. Thanks for watching. See you around.